Hello class, today we are going to look at finding angle measures. So what we're going to do is take all the stuff we've talked about before and we are going to use that to find different angle measures. Okay, so I'm going to flip over to... Alright, so what we're going to do, we are going to find the measures of various angles and we are going to do this with a reason. We have to justify every single thing that we do because we want to prove that we have the right angle. We have it right. Okay, anytime it says find it with justification, that means prove that you're right. All right. Do you have some kind of justification for what you've done? All right, to show that you are doing it right. So what we have here, we have segment AD and segment EG are parallel, and it is not marked. I'm going to go ahead and mark that just so that I can remember that. So these two, that's a terrible arrow, but whatever, are parallel. All right, remember the little arrow means parallel. And see, measure of angle BFC is 70 degrees. Does have that marked on there. Measure of angle GFC is 39 degrees. We want to find the measure of angle FBC. Let's see, so angle FBC. That would be this angle right here. This is what I'm looking for. Okay. So, the way this works, you start with what you're given. Okay, this is kind of setting up into what we call a two-column proof. And so you have what you're saying over here and your reason for why you're saying it goes over here. All right, so we have those two. How do I know that those two are true? Because they were given to us. It's in the problem. So let's see here. I need to find angle FBC. I don't have anything up there. I can do something down here, though. These lines are parallel. That means we have various different relationships between the angles that we can use to find the measures of missing angles. So, for example, let's see. Angle B would be same side interior to angle BFG, right? So if I know what angle BFG is, then I can find the measure of angle B. So that's what I'm going to do. So let's see here. Let me get a calculator. First, I'm going to add these together, and that'll give me the measure of angle BFG. If my calculator will turn on. There we go. Okay, let's clear that out. So we have 70 plus 39, and that gives me 109. Okay, so the measure of angle BFG is 109 degrees. How do I know that? Because I added the angles together. So let's see which one of these says that I can add angles. There we go. Angle addition postulate. Right there. And see, try it. Sure. Hover here to see this. Okay. So now it shows me that. When I hover over it, it shows me that right down there. Okay. So now that I know that BFG is 109 degrees, I can find the measure of FBC because they're same side interior angles. As you remember from the previous video, if they are same side interior angles and our lines are parallel, that means that the angles are supplementary. So now all I have to do is just take that, 109, and subtract it from 180. So let's do that. 180 minus 109, and we get 71. So the measure of angle FBC is equal to 71 degrees. How do I know that? I know that because they are same side interior angles. You are done. Press submit. Submit. Yes. Now, this is not the only way to do it. Notice they did this in 2 steps instead of 3. So what did they do? Well, they found this one here because all 3 of these together have to add up to 180 degrees, right? And well, if this is 71, this angle, EFB, is alternate interior to EFB. It's to FBC. So we can say, hey, you know what? Alternate interior angles are congruent to each other, therefore this is 71 degrees. So you see, there's a lot of times there's more than one way to get this done. So it's okay, just whichever one you see first, that's the one you can use. Okay, so let's try another one here. Okay, so we've got we got a lot of stuff going on here. Let's take a look. So segment AB is parallel to segment DC, okay, and EF is parallel to segment GH. So these two are parallel, those two are parallel, and it tells us that the measure of angle IKD is 123 degrees. We are looking for the measure of AJL. Where is AJL? AJL. So we are looking for the measure of this angle right here. That's what we are trying to find. And we want to be able to prove everything that we do. So I know this is 123 degrees, but angle IKD does not correspond, it doesn't relate to angle AJL because they're not on the same transversal, are they? We don't have one line that connects the two of them, right? So we have to get it there. So let's see, how can I get from here to something that does relate to the angle I want? Well, I either have to move it over here or I have to move it down there. Either way, doesn't matter. I'm going to come over here to angle EIB. So angle EIB, well, let's see. What's the relationship to EIB and IKD? Well, they're corresponding, right? They're both in the same position, so that means they're going to be congruent. And how did I know that? Because they are corresponding angles. And let's try it, see what it says. Yeah, I like that. So that's good. So I know that one is 123 degrees. And what is the relationship between EIB and AJL? Well, those two, let's see, they are not corresponding. Always check that first. Corresponding will be over here. Not corresponding. They are on alternate sides of the transversal, and they are outside the parallel lines. That means they are alternate interior angles. So let's see, that was down here, right? Alternate interior angles. And so what is the relationship between alternate interior angles? Are they congruent or are they supplementary? Yeah, they're congruent. So that means they have the same measure. So AJL is also going to equal 123 degrees. 23, because they're alternate interior angles. No, sorry, not alternate interior angles. They're alternate exterior angles. There you go. Exterior angles, they are outside of the parallel lines. There we go. All right, so pay attention. It will, if you're not careful. All right. Okay, so let's see if we can't find something a little bit different. So let's take a look at this one. Notice in this one, it tells us that segment BE is congruent to segment EC. Those aren't marked. I'm going to go ahead and mark them since it told me that. BE congruent to segment EC. And then the measure of angle BEC is 50. That is marked. And the measure of angle A is 41. That's also marked. Okay. So now let's take a look at this. We want to find the measure of angle AEB. So AEB. We want to find the measure of this angle right there. That's what we're looking for. Okay. So we don't have any parallel lines this time, so we're not going to be using alternate interior, exterior, corresponding, or any of that. So what can we do? Well, let's take a look at what all our reasons are, what we have here. We've got vertical angles. No, we don't have any vertical angles. Linear pair, maybe. We might have something with that. Congruent angles, we don't have the congruent. Some of the angles in a triangle, maybe we can use that. Let's see here. What do the angles, well, we know the angles of a triangle add up to 180, but you have to have two of them, and I've only got one angle in this triangle, I've only got one angle in that triangle. So now I can use that. Sum of the angles of a quadrilateral, I don't think we've talked about that. You may not remember this, but in case you don't, the sum of the angles of a quadrilateral is 360 degrees, but we don't have a quadrilateral here, but that might come up in another one that you have. Let's see here, don't have angle bisectors. Base angles of an isosceles triangle. Let's see, we do have an isosceles triangle, don't we? Right here. Okay, and you may not have learned about this one yet, so we'll go ahead and give you this. The base angles of an isosceles triangle are always congruent. Now the question is, of course, which ones are the base angles? And the base angles are the angles that are opposite the congruent sides. All right, so here I have triangle BEC, and I have two sides congruent, so this is an isosceles triangle. So what that means is that since these sides are congruent, these angles are congruent because they are opposite the sides. So that may be something worth writing down. The base angles of an isosceles triangle will always be congruent to each other. All right, so that means that this angle is congruent to that angle. Can that help me? Yeah, that could help me, because then I can figure out what these angles are, right? Because I have this one is 50, and these two are congruent to each other. So what I can do is I know that those two are the same. So we have, for example, 180, because it's got a triangle, minus 50. Let's just do this. 180 equals 50 plus x plus x, because they're the same. So x times 2, so 2x. So what we can do to solve this, let's see, let me get my calculator up. Turn it on. Okay. We'll take 180 minus 50, and that's going to equal these two angles together, right? Angle EBC and angle BCE. And they're both the same, so I can just divide it by 2. So divide by 2, and I know that angle EBC is 65 degrees. So let's do that. Angle EBC is equal to 65 degrees because it's the base angle of isosceles triangle. And let's see what that says. Yeah, it likes that. Okay. So now that I know that that's 65, I can figure out this one right here. And then I'll have two angles in this triangle, right? Actually, you know what? Yeah, we'll do it that way. So if that one's 65, all I have to do is subtract this, because I've got a linear pair there, right? So I've got a linear pair. Let's kind of erase. What is making noise? I don't know what that is. There we go. Okay, so now I can just subtract this from 65, 180, and then figure out what that one is. So 180 minus 65, no, not that. 65, it's not 60, whatever, 180 minus 65, 115. Okay, so the measure of angle ABC, not ABC, ABE, is 115 because it's a linear pair. Yeah. Now that I know that, I can find this one here, because these three here add together to give me a triangle, so that's 180. So 180 minus 115 minus, what was that, 41 equals 24. So the measure of angle, what order do they have it? AEB? Okay. AEB is 24 degrees because it's the sum of the angles in a triangle. You're done. Press submit. And there we go. All right, so this one is a little bit more complicated. Let's see. We have some stuff that's not marked on here. We have these lines are parallel, so I'm going to go ahead and mark that. So this line is parallel to that line, and AD, okay, and this line is, okay, so this line's not parallel for the first two segments, so I'm going to put two arrows, and it's parallel to that. Okay, so these two are parallel to each other, these two are parallel to each other. So let's take a look, and let's see here, we have segment DE is perpendicular to segment CE, which is marked, because remember perpendicular means it makes a right angle. And the measure of angle DCE is 30 degrees, that's marked. The measure of angle ADE is 56 degrees, that's marked. We are looking for the measure of angle ECB. Okay, so right here, ECB, this is what I'm looking for. Okay, so let's see how we can get there. Well, so we've got some parallel lines, so we can probably use alternate interior, corresponding, or same side exterior, something like that. But this angle doesn't match up with any of the other ones, does it? It's because it's not on the same transversal. So that's no good. So transversal here is EC, and it would be one of these. I don't know. It doesn't work. So let's see if we can find one of these other angles. Let's see. So we've got a triangle here. And I know one angle is 30 and the other angle is 90. So that means I can figure out this other angle. And this angle is, so angle ADC goes with angle DCB. We've got parallel lines, so they're same side interior. So then we can figure this out. Okay. So that's what we'll do. So first let's find measure of angle ECD, because it's inside a triangle. I know two of the angles of the triangle, so all three of them are 180. So I have 30 plus 90 plus x, I don't know what that is, equals 180. So you can just subtract those out and you get, what, that's 60 degrees. Okay, so the measure of angle EDC is going to be 60 degrees because they're all in a triangle. So the sum of the angles in a triangle, and there it goes, 60 degrees. That's marked now. And so now I can find the measure of these two together. All of angle ADC. This whole big thing, we just add those up, and that's easy enough to do. That is 116. So angle ADC is going to be 116 degrees because that's angle addition. We just added the angles. Where is that angle addition? Angle addition, there it is. Right there. So it says, yeah. Right there, 116. So now I can find the measure of angle DCB, this whole angle over here, because remember, the same side interior angles are supplementary. So I'm going to take my 180, because they're supplementary, I'm going to subtract 116, and what do I get? I get 64. So the measure of angle DCB is equal to 64 degrees because they are same side interior angles. There it is. So if this whole angle is 64 and that bit is 30, and I'm looking for this bit, all I got to do is subtract 64 minus 30. And that's easy enough. 64 minus 30 is 34. So the measure of angle ECB is 34 degrees. Why? Because I subtracted the angles. So angle subtraction like that. And there it is. All right. So we're good. So let's see here. I just want to make sure that all of the reasons there that we've covered everything you'll need. Vertical angles, remember they're congruent. Linear pair or triple will add up to 180. Two angles are congruent. You can just say, hey, this is the same as that one because they're congruent. Sum of the angles in a triangle adds up to 180 degrees. The angles in a quadrilateral, which may pop up, it didn't pop up in any of ours, but it may, that is 360 degrees. Base angles of an isosceles triangle are congruent. Remember, those are the angles opposite the congruent sides. Angle bisector is going to be congruent on both sides. It turns one angle into two equal angles. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. It doesn't have same side exterior on this one, but if it does, same side exterior angles are also supplementary. You can add two angles together. You can subtract them if they're adjacent. This is only if they're adjacent. And perpendicular lines form right angles. All right? So they're 90 degrees. So that's all of the different things that you should be using on this. It's not too bad. Hopefully you found that useful. I will see you in the next video.